Hey there, geometry students. Today we're going to work on lesson 31-2 out of your textbook, and it starts on page 453. Yesterday we talked about how to find the sum of the interior angle measures of a regular polygon or any polygon. And today we are going to break that down further and find out how many degrees are in each of the interior angles, and then we'll also talk about exterior angles of a polygon. So a couple of things just as a review. Remember that a regular polygon means that all of the sides of the polygon are the same length. And a regular polygon, in addition to having equilateral sides, that means the same length side, they also have the same measure of angles. Their angles are all the same. So a regular polygon means the angles and the side lengths are all the same. That doesn't mean that the side lengths are equal to the angles, but it means that all of the sides are equal to each other. All of the angles are equal to each other. And again, you've got those definitions over here. So if we complete this table, this kind of carries over from what we saw yesterday. When we have a triangle, we have three sides. We have 180 degrees inside. So we would do 180 divided by 3 to get the individual angle for each of the interior angles. Again, these are regular polygons. That's how we know that we can divide by the number of sides to figure out each individual angle. So then a quadrilateral, 4 sides, 360 degrees, 360 divided by 4 is 90. And then this just continues. You guys can go ahead and fill those in. By the way, a dodecagon is 12 sides. So an n-gon has an n number of sides. In other words, we need to write a formula for, or an equation for, any number of sides. So if we have any number of sides, we saw yesterday that we can find the sum of the interior angles by taking 180 degrees and multiplying it by 2 less than the number of sides. So then that makes sense then to find each individual angle. We would take the total degrees, the sum of the interior angles, and then just divide by the number of sides. So this is how we find the measure of one individual angle, or the measure of each individual interior angle inside a regular polygon. Next, we're going to skip on over to page 455 and talk about exterior angles. So with an exterior angle, you would draw a line or extend one of the sides beyond the point where it meets the other side, and that creates this exterior angle right here. And so there's a couple of different things that we can talk about with the exterior angles. One, if I was going to extend, all of them would go the same way. Like, you only have one exterior angle off of each vertex of your polygon, because if you did it both ways, then you'd be measuring the same angle multiple times. So what we can see here is every time we draw an exterior angle, it creates a linear pair with the interior angle. And if it's a linear pair, we know that they're going to add up to 180 degrees. So if we know the interior angle, we can find the exterior angle by subtracting from 180. Anyway, part 7 here has you go through an example using the GeoGebra software, and they have you actually measure each of the exterior angles, but they've given them to you right here. So you don't have to go and use the software because it's kind of clunky. But what we wanted you to see is that if you find the sum of all of the exterior angles, notice this is a pentagon, if we find the sum of all of these exterior angles just by adding up 90, 70, 74, 71, 55, we get 360 degrees. Okay, and then with the software, they want you to kind of change it to where it's a different hexagon and change it to a heptagon and such, but every time those exterior angles are always going to add to 360 degrees. So that's the part we need you to know. The sum of exterior angles of any polygon is always 360 degrees. Okay, And then it says predict the sum of the measures of the interior angle of a pentagon and one of its exterior angles. Well, that's what we were just saying. If I took this interior angle and added it to its exterior angles, then we're going to create a straight angle. So together they would make 180 degrees. They would be supplementary. They make a linear pair. Okay. Now up above on this page, there was one little piece of vocabulary that I want to draw your attention to, and that is the word convex. So convex polygon is a polygon where no line containing a side contains a point in the interior of the polygon. It's kind of really confusing the way that they've given you the definition. So let me show you what a non-convex polygon would look like. Okay, this is a concave, or you can call it a non-convex polygon, because I could draw a line across it and there's like a cave here. I could cross two sides at once with one line. So if you see these little caves, then it's concave. But see, I don't have any caves or dips inward toward the inside of the polygon, so this one is convex. And this one is concave or non-convex. That will definitely come up on your exam and on your quiz, so make sure that you look at some different examples. There are some videos on our Moodle page, and you can also just Google convex polygon, concave polygon, and see some examples. So let's go ahead and look at the next page for our homework. So on page 456, your homework is mostly focused on finding the individual interior angle measures in regular polygons and also finding exterior angles. So your homework is going to be page 456, number 18, 19, 20, 21, 22. Make sure that you check your answers on Moodle. The answer key should be posted. And then if you are struggling, check out the Khan Academy videos, and you can also visit Coach Russell. He's taught geometry before also, and he is happy to help. Otherwise, we'll see you tomorrow.